This last lesson looks at angle properties in polygons. So first off, a couple definitions. A polygon is a closed shape with straight sides. So here on the example on the left, this is a polygon. The example in the middle is not a polygon because of this curved side. And the shape on the far right is not a polygon because it is open. It's not a closed shape. So it has to be a closed shape, straight sides. We can also break up polygons into concave polygons and convex polygons. A convex polygon has no angles pointing inwards. So more precisely, no internal angles can be more than 180 degrees. So here we have a convex polygon, and a concave polygon is if there are any internal angles greater than 180. So here's a concave. And I like to think of concave, it's like when you kick in a watermelon, when you cave it in. So this point here would be a concave polygon when I have one side that's pushed in. We can also break up polygons into regular or irregular. If all angles are equal and all sides are equal, then it's a regular polygon. If it has unequal sides and unequal angles, it's an irregular polygon. The interior angle of a polygon is when it's inside the shape. You can create an exterior angle by extending one of the lines, and then you have your exterior angle. There is some patterns when we look at the sum of interior angles in polygons. The first one, a triangle with 3 sides. It is made up of just one triangle, and we know from before that all 3 sides add up to 180. If I have a square, I could break up a square into 2 triangles. And in a square, each corner is 90 degrees. There are 4 corners. A triangle has 360 degrees. In a pentagon, a 5-sided shape, we can break it up into 3 triangles. 3 times 180 is 540. All 5 of those angles added together is 540. A 6-sided polygon, so a hexagon, can be made up of, I can do it in 4. Let's see here. 1, 2, 3, 4. There we go. So I can make a minimum of 4 triangles in a hexagon. So 4 times 180 is 720. Is there a pattern that we're noticing here? So looking at the top beam of the triangles, we go from 3 sides, we can make 1 triangle. 4 sides, we can make 2 triangles. 5 sides, we can make a minimum of 3. 6 sides, we can make a minimum of 4. Our pattern here is that whatever the number of sides is, if we subtract 2, we get the number of triangles. So n subtract 2 would give me the amount of triangles. So if I wanted to figure out the sum of interior angles, I would take n subtract 2 and times it by 180. This here would be your formula, and I'd like you to write that down. So, how can we solve for the sum of just one angle if we know the sum of all the angles? We can divide by the number of sides, so those angles. So here would be the formula if I wanted to solve for just one angle, where n is representing the number of sides. Here are your formulas one more time. So if you wanted to solve for the sum of an interior angle and subtract 2, times it by 180. If you wanted to solve for just one angle of a regular polygon, because a regular polygon, all the angles would equal each other, and subtract 2, times by 180, and then divide the whole thing by n. So here is an example. We have a regular decagon, which is a 10-sided polygon. The sum of interior angles, we're going to write that formula there. So 10 subtract 2 times by 180. So that's 8 times 180, which is 1,440. Because this is a regular decagon, each angle is equal to each other. So if I wanted to solve for just one angle, I would take the sum of all of them, 1,440, and divide it by the number of sides, which is also equal to the number of angles. So there's 10 angles in a decagon. So each angle is 144 degrees. And there's your slide with the answers. Now, here is another informational slide. The exterior angles of a polygon add up to 360 degrees. So in other words, the exterior angles add up to one full revolution. This works for any polygon. If it was a square and we extend our lines to create exterior angles, each one is still 90. 4 times 90 is 360. Now notice if I went from this 4-sided shape to this 5-sided shape over here, the pentagon, these exterior angles are getting smaller. There's more of them, but they're getting smaller. So it doesn't matter how many sides my polygon has, all the exterior angles will add up to 360. Here's another example. Outdoor furniture and structures like this gazebo sometimes use a regular hexagon. A hexagon has 6 sides. Determine the measure of each interior angle of a regular hexagon. So we want each measure, so that one single angle. So that formula we have 6 subtract 2 times it by 180, and because I want to know what just one of those angles is, or r, I'll divide it by 6. So 4 times 180 divided by 6. And we get 720 divided by 6, which is 120 degrees. Each angle is 120 degrees.